If you're just starting your game dev adventure or you're trying out a new game engine, it's good to start with basics. 2D platformer game. We'll create it in Godot, a free and open source engine that will allow you to create your first dream project. We'll be touching a lot of concepts, so stick to the very end to collect all the badges. If some of the workflows require revision, don't forget to explore video chapters at the bottom of the video. After each chapter, you will receive a new badge. First, let's install Godot. Visit the official website, click Download Latest, and then Godot Engine. After installation, you will be greeted with this screen. Press New Project, browse the path, and create a new directory that will hold all your future Godot projects. Give your new project a name and click Create Folder. That way, you will have a nice structure for this and future projects. As for the renderer, select Mobile option. It's the best choice for 2D game. Click Create and Edit. This is the Godot main editor window. Here we'll be doing all of our work. As you can see, there are multiple panels and tabs, which we'll be discovering along the way. First thing we need to do is to create our scene. Scene is a container that gathers all the in-game components, both static and the dynamic ones. As you can see here in the top left, Godot gives us some starting suggestions, but I would prefer to have a blank canvas. Click on Other Node, and from this square window just select Default White Node and click Create. This will be our root of the scene and all other components will be a child of it. That helps to keep our project tidy. Before we'll start adding child nodes, we need to save our scene. Just click Ctrl or Command S, name it main.tscn, which is a Godot scene format, and click Save. After it's saved, you can find it here in the file structure of a project. Congrats! This is your first badge. Today we'll create only 2D elements, so here at the top select 2D mode and zoom into the blue border. It represents our game window. Our scene will consist of 3 main elements: background, ground blocks where our character will be able to walk, and a character. Let's start with the first one. Today, for all the graphics, I'll be using this awesome free pack called Pixel Adventure. Download it from the link below. I'll take the green background image and drag it into the Godot file system section. That way, it will become a part of our project. To fill the whole background with it, let's create our first node. Click on this small plus icon in the Scene tab and search for Texture Rect node. Click Create. This component allows us to show an image on the scene. Simply drag this image from the file system to the texture field right here. That way it shows up on the scene. Now I would like to resize it to the whole size of the screen. Resizing manually is not a good idea because everything may break after the window resizes. What we need to do is to click on this small green icon at the top and from the Anchor presets select Full Rect. To learn more about Anchor presets, you can check out this video. Two other small tweaks. First, I don't like that this pixelated image is being blurred. To fix that, here in the inspector find the texture section and change filter to nearest. Much better. And the second one, instead of stretching this image, I'd like to tile it. Here in the stretch mode, select Tile. Great! Now let's create a ground on which our character will be walking. For that, we'll use a grid tileset system which allows us to easily paint our scene objects. You may recognize it from many popular games, both in the side view and in the top-down view. I'll import this terrain file. To use it, let's create a new node. Right-click on the root, select Add Child Node and search for Tilemap. To start drawing tiles, we need to do a one-time configuration of a tileset. Here in the inspector, click on Empty and select New Tileset. In this new window on the bottom, we only need to drag our terrain image here. Click Yes, and Godot will automatically split our tileset for us into small individual tiles. Now to draw them on the scene, simply switch the tab on the bottom to Tilemap, select Tile, and start dragging your mouse on the scene. Again, two small things to make this experience better. First, let's increase the size of our tiles so that everything will be bigger on the scene. Go to Transform and change scale to 3. And the second one, if we zoom in, we can see the same problem with smoothing out pixels. Go to Texture and set filter to Nearest. Way better. Now is the time for you to become a level designer. You can play with all the available tiles and tools like Paint, Line or Rectangle. You can also select multiple tiles at once and paint them in batches, and when you make a mistake, just use an eraser to clean it. Now I'll take a second to design my level. In the meanwhile, you can leave a like under this video if you're enjoying it so far. Also, here is a silver badge for you. You'll learn one more skill related to tilemaps later in this video. Alright, here is what I created. I think it will be a nice level to play around. Remember to place some bricks around the scene so that player does not fall off the map. But obviously something is missing, our main character. Time to create one. Create a new node called Character Body 2D. It should be a child of a root, so if you made the same mistake, just drag it like that. Character controller needs to have two children, Sprite that will define its image, and a collider that will define what touches the ground and collides with other elements on the scene. Let's start with the first one. Create a new node called Sprite 2D. Similarly to the background, it also waits to add a texture to it. I will import this ninja frog and set it as a sprite texture. If you think your character should be a bit bigger, simply resize it. And again, just like with all other images, I'll change the texture filter to Nearest. Then Collider. Select the character body and add a new node called Collision Shape 2D. For now, it hasn't created any collider because we need to change a setting here in the inspector. Instead of empty, go with the rectangle shape 2D. That created this blue box. Don't worry, it won't be visible in the game, it only visualizes what shape will collide with other objects. Resize on the bottom edge so that it will reflect the place where the player will be touching the ground. Colliders on the sides are not that important, but you can simply resize them to the entire frog image. These are the basics of creating sprites. Good job! If you'd like to create enemies, you can do so by using the same node structure. Remember to experiment with different collision shapes. Time for the very important skill, creating subscenes. Our character is initially placed here in the corner, obviously not an ideal place, so I'm gonna move it. The problem is that I'm not moving the whole parent, but only the collider or the sprite. To move everything, we need to create a subscene. We can also call it a group or a prefab if you're coming from Unity. Right-click on character body and select Save Branch as Scene. Now we need to set the location. Create a new folder called Scenes, rename our scene as Main Character and click Save. That did two things. First, we can now find our newly saved subscene here in the file system, and the second, our few nodes have been combined into this one. I can now freely move this object with all of its nodes at once. If you like to change anything for this character, just double click it. That will open a new tab with only this scene contents. What is really important, anything changed here will also apply to the main scene. For example, I will change the collider shape to capsule, resize it a bit and press Command or Ctrl S. Now in the main window, this change is applied. That can be even more useful for changing multiple subscenes at once. For example, here I have an enemy subscene that I placed a few times in our world. If I open it, change the rotation of the sprite and save it, you can now see that all of the enemy instances have been updated. Remember to often create subscenes to keep your project tidy. Let's try to play our game. Here in the top right, click Run Project. A new window will appear and after a second of loading, you should see your amazing game. For now we can't really do much. Our character is not moving. Let's fix that. Go to the main character scene, click on the root node and click the small add script icon. We leave all of those values by default, but let's quickly go over them. First, you select your programming language. We'll go with GDScript, but if you'd like to try out C#, check out my other video and follow the script alternative version shown on the screen. Then select a template. Godot has a built-in template for moving 2D characters, which we'll use for sure. And finally, set a file location and name. It's a good practice to name it the same as the scene. Click Create. Whoa, as you can see, Godot has switched to the script tab. If you like to go back to the editor, you can do it here. This is the template code for the character controller. The good news is that it already works and we can test it out. Go to the 2D tab and save the scene. Notice that the unsaved changes have the small star next to them. Press play. Now our game starts, the main character starts falling and falls through the map. What's wrong? The problem is that our whole character has the collision, remember this blue box shape, but our ground does not. The game simply doesn't know what to collide with. The fix is very easy but requires a few clicks. Select the tilemap in the Scene tab, then here in the inspector click on TileSet, then Physics Layers and click Add Element. Now go to this bottom section, select TileSet tab. Don't mistake it with tilemap. In a Paint tool, set Paint properties to the Physics layer. And finally, paint all the tiles that should collide with the player. In my case, all of the ground tiles and the rope. And that's it. Now when I press play, our character will start colliding with the ground. Perfect! To control it, use keyboard arrows, and to jump, press space. Congratulations on creating your first movement controller in Godot. Before we'll move on with a nicer movement, I'd like to quickly go back to our sprite appearance. Currently, it just stands without any life. We can easily fix that by giving it a simple idle animation. Go to the main character scene. I would like to replace this sprite with a node that enables animation. Right-click on it and select Change Type. We'd like to change it to the Animated Sprite 2D. Our image disappeared, but don't worry, we'll quickly revert it. In the inspector, select Animation, and next to the sprite frames, click Empty and select New Sprite Frames. I'd like to use these idle animation frames, which can be found in a pack. Import them to Godot, and here in the Sprite Frames panel on the bottom, click Add Frames from Sprite Sheet. Select Idle Animation File. Here Godot is asking us how we would like to split this image. In this case, I know that each frame is 32 by 32, so we can enter it here. Alternatively, you can also experiment with horizontal and vertical values until the image will be split correctly. Then we need to select all the animation frames. Simply click on the first one and drag your mouse along all the others. That will create 11 frames. Add them. Now our animation is ready. To preview it, click this play button. If the animation seems a bit too slow, you can increase the frames per second value. Before we'll move on, let's create two other animations that we'll use later on. Jumping and running. For jumping, that will be only one frame we've used before. I will just click Add Frame from File and import this fall image. For running, we'll use this sprite sheet. Go ahead, pause the video and try to add it right now. Alright, here is what you need to do. Import running image. In the sprite frame, switch to the running animation and press this button. Select the file, slice it properly, select all the frames, preview the animation and change its speed. To play the animation in the game, select the default one and press the small button that will turn on autoplay on load. That's it! Play the game and enjoy how our character plays the animation. We'll work on implementing the other animations a bit later. As promised, let's get back to the scripting. As you can see, our movement works, but it's quite lifeless and stiff. Time to change that. Switch to the script tab and look at main character script. It is very short and quite understandable thanks to the comments. Basically what's happening is that 60 frames per second we are doing three things. First, we check if our character is not touching the ground, which means it's in the air. In such cases, we apply a gravitational force that pulls it towards the ground. It's worth noting that in Godot, the y-axis operates differently than the standard graph convention, with positive values directed towards the bottom. Then we check if player is both on the floor and has pressed jump button. In such case, we should increase the velocity towards up. And lastly, we check if player is clicking either right or left button. In such case, we should change the velocity towards either of the sides. And that's it, pretty simple. We'll have 3 tasks here. Flip character right or left depending on the movement, play character animations depending on what's happening, and finally make walking and jumping a bit smoother and nicer to play with. Let's start with the first one. If we take a look at our animated sprite, you can see that in the offset section there is this nice toggle to flip sprite graphics horizontally. We need to toggle it in the script depending on what was the last player velocity direction. Accessing nodes and their values in the script is very easy. Switch to the script tab and start dragging Sprite 2D node from the scene to code like that. Very important, just before the mouse release, hold the Control key. That will create a reference that can be used in different parts of the script. Now at the very end of this function, we simply need to add 2 lines. var is left, that will be a variable that will check if player is facing the left or the right side of the screen. We know that by checking if the velocity .x is lower than 0. If player is facing left, that means that we'd like to flip its image. Type sprite2d .flip_h, which stands for horizontally, equals is left. That should be it. Run the game and notice how our character is changing its size depending on the movement direction. Next, playing different animations. Now that we have a sprite animator reference, that will be very easy. As a reminder, we have 3 animations: default, jumping, and running. To change animation, for example while jumping, just type here sprite2d.animation equals jumping. Now whenever our character is in the air, the jumping animation starts. To implement animations for walking and standing, here is the code I will add at the very top of our function. If velocity.x is greater than 1 or lower than -1, we need to cover both right and left movement, then sprite2d.animation equals running, else sprite2d.animation equals default. Remember that those strings need to have the exact same names as defined earlier. Now press play and notice how our character is nicely animated. It even plays jump animation when falling off the hill. And the last step, where all the magic will happen, will tweak some controller values. First, I like to look at this line. What it does is that when the player stops holding the right or left key, the character should gradually slow down. Function move toward takes current velocity, which at maximum is currently 300, and brings it slowly back to 0 using steps. The problem is that by default the steps are defined using the same variable as the maximum speed. That causes the instant speed drop when the key is no longer pressed. I would suggest inputting something smaller here, for example value 10. That way we'll get this fun slowing down effect. What is great about Godot is that you can tweak some variables without stopping the game. For example, if I would change that to 4 and save, the player will behave as it is on the ice. I think 12 is an optimal value. Now how about the other values? When you scroll up, you can see those 3 variables. Speed, which is a max speed character can travel with, jump velocity, and gravity. Let's start with the last one. Its value is taken from the project settings. So go to project, project settings, search for gravity, it will be in the physics 2D, and change it to something bigger, like 2500. I'll increase the speed to 400 and the jump velocity to -900. Remember, minus values are going upwards. After all of those changes, press save, start the game, and try it out. In my opinion, it's way better than what we started with. That was a long chapter, so here is a great reward. Scripting gold badge. Good job! Time for the last quick addition. For now we can only use arrows and space to control our character, but what if you'd like to add other keys? When you check out the script, you can see that we define key presses using these UI accept, left and right. This is not ideal. Those mappings should be used only for the user interface, and in fact, code comments tell us exactly that. We need to replace them with manually defined actions. Go to Project, Project Settings, and select the Input Map tab at the top. Here we can declare actions and key mappings. Here type left and press return. I will also add the same way, right and jump. Under each of the sections, we'll define all keys that should trigger it. Click the plus icon next to the left action and press the left arrow key. It should automatically find the key you are looking for. I will do it again for the A key to enable A and D movement. Finally, if you'd like your game to support the gamepad, you can search for left stick left and D-pad left. I think that should be it. Now pause the video and complete this input map with all the remaining key combinations for your game. Alright, here is my final configuration. To apply it in the code, all we need to do is to replace those UI something strings with jump, left and right. That's it! That way you just completed all the badges for this video. Congratulations! If you liked this tutorial, subscribe to Coco Code and check my other videos. As always, big thanks to my awesome patrons that support this channel. Visit a link under the video to join them. See you soon!